Alright guys, let's get some homework done. We are working on 8.1 polynomial functions. This is the homework tutorial. You were to do odds on the front and evens on the back. Let's get started. Okay, the first thing we want to do for number 1, 3, and 5 is write each polynomial in standard form. That means get it in order from the greatest exponent to the least exponent. Then we're going to classify it by degree and number of terms. Okay, so we have 4x cubed, thank you, minus 3 plus 2x squared. All right, my first term, my highest term is the 3. So let's change a different color than that. Let's try to see how this one looks. Okay, does that work? I want something brighter than that. Let's try this yellow. Okay, so we're looking at the 3, so we have 4x to the third power. Then we go to the 2, so that's plus 2x squared. And then we have no x, so that is minus 3. So now we have it in standard form. We look at our largest exponent, that is a 3. So our notes show us that box on our notes shows us that is, for 3, it is cubic is the name of that degree. And we have 1, 2, 3 terms, so this is a trinomial. Okay, so number 1 is a cubic trinomial. Number 3, okay, we have 4 as our highest exponent, so we have 2x to the 4th power plus 6x minus 2. That puts us in standard form. 4 is our largest degree. That is quartic. So quartic, and we have 1, 2, 3 terms. That is a quartic trinomial. Okay, and then number 5. Put this in order. We have 24x squared plus 3. Squared tells us this is a quadratic. Yes, I understand the quad makes you think of 4, but don't think of it that way. Quartic, think of quarter 4, okay? 4 quarters to a dollar, so 4th power is quartic. Not quadratic. Quadratic is squared. And then we have 1, 2 terms, so that is a binomial. Okay, so a quadratic binomial for number 5. Alrighty. Number 7, 9, 11, and 13, we're going to determine the end behavior of the graph of each polynomial function. First, we're going to get it into numerical order, or the standard form. So y is equal to 4x squared minus x plus 5. Okay, now we are going to look at the exponent. That's a 2. Didn't really like that. Let's just underline it. Okay, and that tells me that it is an even exponent, so my end behaviors are both in the same direction. Okay, and then I look over here and I see that I don't have a sign, so that tells me my sign is positive. So I have end behaviors going in the same direction. It's positive, so this is up, up end behavior. Okay, let's look at number 9. Number 9, we're going to do y is equal to 3x squared minus, let's try that again. I looked at that backwards. Negative x cubed, there we go, plus 3x squared plus 9. Okay, now, again, we have a 3 for our exponent. That is odd. That tells me, remember, odd, opposite, ODD, OPP. So they are going in opposite directions. I have a negative for my sign. So that tells me that I start up and I go down. So I start up and I end down. Okay. Number 11, y equals negative x to the 5th power plus 20. I have the 5th power, so I have it's odd, so they'll go in opposite directions. It is negative, so again, we start up and we go down. Okay. All right, last one on this page. Number 13. Okay, looks like 6 is my highest power, so I have y is equal to negative 5x to the 6th power. Then I go to a 3, so I have minus 22x cubed. And then we have the first power, so plus 2x, and then plus 15. Okay, so there's our new equation. We have a 6, that is even, that means they are in the same direction. We have a negative, so it starts down, and so that it will therefore end down. So here we have down, down, end behaviors. All right, number 15 and 17. The directions say describe the shape of each cubic function by determining the end behaviors and the number of turning points. And on number 15, it tells you, gives you the hint, says to start, make a table of values to help you sketch the middle part of the graph. So we're going to do that for -2 to +2. So x and y's, -2, -1, 0, 1, and 2. So I have -2 is at -12. -1 is at -3. I have 0 at 0. I have 1 at 3 and 2 at 12. So let's just kind of graph that out and take a look at it. So -2, -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's get some bigger dots here. Okay. And then we have -1, -3, 1, 2, 3. We have 0, 0. And then we have 1, 3, 1, 2, 3. And then we have +12 right there. Okay, so that gives us a graph. Oops, I don't really like the way I did that. All right, now we can see that we start down, we end up. So down, up is our end behaviors. Our number of turning points. We kind of see a bend here and a bend here, but it never really changes directions. And we can tell that by looking at our y values. Because from -12 to -3 to 0 to 3 to 12, we continue to go in the same direction. We never switch directions, right? So because of this, this tells me I have 0 turns. Okay? All right. Let's look at number 17. Number 17, clear out my calculator, 4x to the third power plus 2x squared minus x. Okay, and when I look at my x's and my y's, again, we're going to go from -2, -1, 0, 1, 2. -2 is at -22. -1 is at -1. 0 is at 0. 1 is at 5. 2 is at 38. Okay, so I'm not going to be able to get the -22 and the 38 on here. So we're going to do the -1, -1. Oops, let's get those points in here. There. 0, 0. And then we have 1, 5. 1, 2, 3, 4, 5. Okay. And oops. And then it's going to go really high up there. Okay. So we can kind of see between 0 and, -1 and 0, we can see a little bit of a turn. Not turn, but we can see some shifting there. So let's go in and look a little bit closer on that. Okay, so I'm gonna go to my table set. I'm gonna start at -1. Okay, and I'm gonna go to 0.1. Okay, and I'm gonna go to my graphs here. So between 1 and 0, or -1 and 0. So let's do this again. Oops. Okay, x and y. So I have -1, and I have -0.9, -0.8, -0.7, -0.6. -0.5, -0.4, -0.3, -0.2, -0.1, and 0. Okay. So at let's just start at 0 because that's where my calculator is. At 0, we have 0.
I'm tired.
At -0.1, we have 0.116. At -0.2, it's 0.246. At -0.3, we have 0.372. -0.4 is 0.464. -0.5 is at 0.5. -0.6 is 0.456. -0.7 is 0.308. -0.8 is 0.032. -0.9 is negative 0.3996, and then negative 1 is at negative 1. Okay. Okay. And then it looks like we need to go a little bit further. So we need to go 0.1, 0.2, 0.3, 0.4, and 0.5 looks like here. At 0.1, it's negative 0.076. Negative, 0.2 is negative 0.088. 0.3 is at negative 0.012. 0.4 is at positive 0.176. And 0.5 is at 0.5. Okay, so let's see. We start at negative 1. We go up to 0.3, up to 0.032, up to 0.308, up to 0.456, up to 0.5. Okay, so that's going up. So that's positive. And then all of a sudden we start going back down. We go at 0.464, 0.373, 0.246, 0.116, 0, negative 0.7076, negative 0.088, negative 0.012. Okay, so we started going, let's come back up here a little bit. Okay, so we hit here at 0.2, and we got to a low point of negative 0.088, and all of that was going down. And then we make another turn, and at 0.3, all of a sudden we're at 0.012, and then 0.176, and then 0.5. So we're going back to the positive side. So we've got a turn here, and we have a turn here. So we actually have two turns. So let's write this where we can see this. Okay, so our end behaviors, we have is bottom to top, so our end behavior is down, up. Okay, and we actually have two turns. So see, sometimes we have to get really close in there. So this area right in here, let me see if I can get this small enough. This area right in here, actually to about right here, actually is kind of, let's see, we're going up to here, and then we're going back down to here, and then back up. So we actually have turns in there like that. Okay, so we have turns here and here. There we are. Okay, and if you graph that out on your calculator, and then you do a zoom in and hit enter, do zoom and then in, let me graph that, zoom, and then in is 2, and then enter, and when you do that, it pulls it up into a close-up and shows you what that looks like My graph's a little bit off, but you can see it if you put it on your calculator. I'm a little bit short. But anyway, that's where your numbers are. Okay? Alrighty, let's go on. Okay, with this one we're going to use differences to find the degree of each polynomial. So, remember we're going to subtract one number from the other. We're going to start from the bottom and work up. We're working with our y's. Okay, so I'm going to start from the bottom. I'm going to go 95 minus 25 gives me 70. 25 minus 5 gives me 20. 5 minus negative 1 gives me 6. Negative 1 minus negative 5 gives me 4. Negative 5 minus 5 gives me negative 10. 5 minus 65 gives me negative 60. And this is my first difference. Okay. Now we're not to a constant number. I don't have all my differences being the same number. So I'm going to try again. So I have 70 minus 20 gives me 50. 20 minus 6 gives me 14. 6 minus 4 gives me 2. 4 minus negative 10 gives me 14. And then 10 minus negative 60 gives me 50. Okay, well, I'm seeing some patterns, but that's still not it. That was my second difference. Okay, now let's do one more. Okay, so we have 50 minus 14 is 36. I have 14 minus 2 gives me 12. 2 minus 14 gives me negative 12. 14 minus 50 gives me negative 36. That's my third difference. Okay, still not there. Patterns are getting tighter, but we're still not there. Alrighty, let's try this again. 36 minus 12 gives me 24. 12 minus negative 12 gives me 24. Negative 12 minus negative 36 gives me 24. This is my fourth difference. Okay, now I finally have all my numbers the same number. My difference is 24 now, and this is in my fourth difference, so this is my fourth degree. My fourth degree means this is a quartic polynomial. Okay. I know it's a lot of work, but to me they're kind of fun. Kind of looks cool, especially when you do it in color. Okay, number 20 and 22 says determine the sign of the leading coefficient and the degree of the polynomial function for each graph. Now, it says on here, well, we were told that the degree minus 1 equals our number of terms. Right? Okay, So if I know my number of turns and then I add 1 to it, so number of turns plus 1 equals my degree, right? Okay, so let's take a look. I start at the bottom, I go up, I turn a point and go down, and then I go back up, right? Okay, so I have 2 turns. If I take 2, I add 1 to it, my degree is 3. So this is a cubic polynomial. Okay, and it says determine the degree of the polynomial function. So we started down, we ended up. So if I start at the down position and end in the up position, this means that I have a positive cubic polynomial. Okay, so now let's check out our second graph. Okay, I start up, I come down to a point, and then I come back up. Okay, so I have 1 point. So if I have 1 turn and I add 1 to it, that means I have a degree of 2. So that is a quadratic polynomial. Okay, and I have up as my end behaviors. That tells me that my coefficient is positive. So I have a positive quadratic polynomial. Okay, we get to do another one of these fun ones, and we can use some multiple colors and have a little bit of fun with this. It says the table shows data representing a polynomial function and wants to know what is the degree of the polynomial function, what are the second differences of the y value, and what are the differences when they're constant. Okay, so let's take a look. We have 230 minus 48 gives us 182. 48 minus 2 is 46. 2 minus 2 is 0. 2 minus 6 is negative 4. 6 minus 20 is negative 14. And 20 minus 98 is negative 78. That's our first difference. Right? Okay. Different color. 182 minus 46. 182. Ooh, do I like that? I don't like that color. Let's try a different color. 182 minus 46 is 136. 46 minus 0 is 46. 0 minus negative 4 is positive 4. Negative 4 minus negative 14 is positive 10. I want to make sure. My brain's getting tired. So, and then negative 14 minus negative 78 minus negative 78 is 64. That's our second difference. Okay, and guess what? There's the answer to our B. Okay, our second differences of the y value are 64, 10, 4, 46, and 136. Okay. Now, let's do the next one. Get a different color. Let's go light green this time. Okay, 136 minus 46 is 90. I don't like that one. Let's make something that's a little brighter. There we go, neon green. So 90. 46 minus 4 is 42. 4 minus 10 is negative 6. And 10 minus 64 is negative 54. Okay, and that is our third difference. Okay, and one more. Let's go with let's see. Kind of an aqua color. Will this work? Yeah, that'll work. Okay, so 90 minus 42 is 48. Oh, wait. 90 minus 42 is 48. There we go. 48. 42 minus negative 6 is 48. Negative 6 minus negative 54 is 48. This is my fourth difference. Okay, so what is the degree of the fourth of the polynomial function? This is the fourth degree. Okay, or you could write quartic. Oops. Okay, and what is the difference when they are constant? 48. Okay, last section. Okay, says classify each polynomial by degree and number of terms. Simplify first if necessary. So number 26, let's simplify that. We're going to put that in order and we're going to say 3a squared minus 2a plus a. And that gets it in standard form. We look and we've got a quadratic. It's squared, so it's quadratic. Okay, and this is 1, 2, 3 terms, so it is a quadratic trinomial. Okay. All right, number 28. We have c cubed times 5 minus c squared. So we're going to distribute. Okay, so we have 5c cubed minus, I have c 3 times c squared gives me c to the 5th power. So that comes down to negative c to the 5th power plus 5c cubed. 5th power, that's quintic. And I have 1, 2 terms, so that is binomial. So a quintic binomial. Alrighty. Now, number 30. Number 30, we've got x times 3x times x plus 2. We work left to right, okay, when we're multiplying. So we're going to take first and distribute x into the 3x. That gives us 3x squared. And that's multiplied by x plus 2. And then we distribute that inside, and we end up with 3x to the 3rd power plus 6x squared. My highest power is 3, so that is cubic. I have 2 terms, so it is a cubic binomial. All right, last one. We have the number 5. Okay, there's no x. So that means I have a power of 0. And when I look on my list, my power of 0 is a constant. And I have one term, so this is a monomial. So number 5 is, so 5, the number 5 is a constant monomial. All right, guys, that does it for tonight. Have a great night. See you tomorrow. Have a great night.